everyone. Good afternoon. I like to think that it's the quality that matters, not the quantity. 5 p.m., it's a hard slot, but thanks for coming. So this is going to be a fun session. For those of you who are here, by the way, raise your hand if you can still walk. All right, fine. My name is Lior Kamrat. I'm Principal Product Manager, lead, part of the Azure Jumpstart team. We have a packed session for you today.
Hello, everyone. Francisco Cabrera here. I'm a Senior Product Manager at the Azure and Platform team also.
So today's session is really about architecture patterns, scale apps and data, Azure Arc, Kubernetes, Microsoft Fabric. I think the title is not encapsulating the amount of stuff that we're going to have here today. So we're just going to get going, I think that's a good plan. Don't be shocked that we're going to have AI. All right, I'm just saying. I just want to set expectations with all of you. I feel that we're getting some relationship here going on. So I just want to set expectation. All right, so what are we going to cover today? Today we're going to cover some of the Azure Adaptive Cloud approach. I'm sure that you might have heard about this throughout the week. I'm not going to go way, way deep into the weeds of this because, like I mentioned, we have a lot going on. Then we're going to talk about our reference customer. All right, maybe you bought some stocks of 𝗦𝗲𝘀𝗀𝗶cie Supermarket this week. If you were, great. Securely deploy AI models at the edge. Scaling AI applications across physical boundaries sounds good, Data-driven, we're going to talk a bit about the architecture patterns around data pipelines. We have multiple things going on in that space. And finally, we're going to share with you how to get started and share with you some announcements that we made this week that we think that you'll enjoy. Sounds about right? Sounds like a good plan? All right, let's get going. Cool. So we started this week, just kind of recapping Azure Adaptive Cloud approach. Now, here's the thing. We announced this thing a year ago at Ignite, and since then, been booming. The reason for that is because, one, there was a bit of ambiguity going on when it comes to Azure Adaptive Cloud. What does that really mean? So I'll tell you what it means to me, okay? For me, Azure Adaptive Cloud approach is really about the sprawling systems and the complexity and how we're trying to solve for that. Obviously, there's a lot more to unpack here. There's a lot of technology involved. There's a lot of things going on, right? But for me personally, Azure Adaptive Cloud approach is really how we go and solve for complex, messy, and real environments, right? Using the technologies that we have, right? So Azure Adaptive Cloud approach is really our approach to get going with all things Azure Arc, Kubernetes at the edge, Azure Local, right? And all the things that are in between, data pipelines, Azure IoT operations. There's a lot to unpack, and we're going to cover a lot of that today. So we're going to use 𝗦𝗀𝘀𝗀𝗶cie hypermarket in this session as our reference customer. We're going to build on that because we're going to show you some of the complexities that they're dealing with, right? And how do we go about and solve for those complexities, right? And we want to make sure that you have the right knowledge in order to implement this type of stuff in your environment, or at least get a sense of what is the art of the possible. What are the things that we're coming up with? What are the things that you will be able to do in the future as well? All right? So 𝗦𝗀𝘀𝘀𝗀𝗶cie hypermarket, they're a global global retailer, right? So if you are in the US, Costco is a great example to how to think about them, like in terms of scale, in terms of operations, right? And obviously, there are a lot of other retailers out there in Europe and other continents that are fitting into this model, right? The important piece here is that this is not just about retail, okay? Because at the end of the day, every customer today, they don't just fit into one industry. And this is really the sprawling system aspect of it, okay? So if you're going to stick around, and I hope you will, because we don't have a lot of people, so just stay, right? I think that, that would be good. We're going to cover multiple scenarios today. We're going to cover footfall, shopper insights, and predictive analytics, okay? Those are the three scenarios we're going to cover today as an anchor to the technology implementation that we're going through, all right? So I mentioned the sprawling system, right? So this is really how it looks like. So this is the real implementation or the technology and operational stack of 𝗦𝗀𝘀𝘀𝗀𝗶cie hypermarket. Every single component that you see here is something that we used in order to simulate that customer, right? And the reason that I wanted to show you this slide is because the real world is messy, and I'm sure that you will agree with me. This is no, unicorns, butterfly, tight kind of operation. This is messy. There's a lot of things going on. So what we're trying to do is we're trying to show you the relationship between all these sprawling systems and how those fit into legit architecture patterns, all right? So, Francisco?
Thank you. Well, so this, as you saw last slide, there's a lot to unpack. So we're going to start, different buckets of things that we want to talk about, how we actually deploy this Contoso hypermarket. And for that, we're going to start first with, how you actually bring these AI models in a secure way to the edge, right? If you actually think about these models are just bits, but they can contain a lot of, critical information for the company. So how you make sure that when you bring those from the cloud to the edge, you do it in a secure way. And when we talk about these security challenges, right, the first one is actually secure pooling. Make sure that, while you're transferring those bits from the cloud to the edge, you're doing, right, with TLS, HTTPS, whatever you want, but in a secure way. The second thing there also is that you need to make sure the integrity. So is the same model that I had on my cloud, it's the same as, on the edge? Was it altered in the middle? Then we also need to consider role-based access control. So basically, it's who can access the model and how. Can they read? Can they execute? Can they write? And finally, encryption and isolation. While your model is at rest on that kind of Kubernetes cluster, can you isolate it? How can you encrypt it so that nobody can just go ahead and get those bits? So we're going to be doing a really kind of quick demo here. I'm going to explain it a bit. We have this part of the footfall scenario of Contoso hypermarket. You can see this architecture diagram. And the first thing that you'll need is, of course, a model. And the model you want is choose whatever you want. You can use Azure AI Foundry. You can use OpenVINO, Hugging Face, whatever you want there. It's just, right, it's this black box, they're bits. And you'll have to put it in a place where you can download it directly from your Kubernetes cluster. And you may think about maybe you can use a file server, you can use storage. But in the end, containers and models, they're bits, right? So why not just go ahead and use what we've already been using for the past 10 years? Those are the container registries, right? And if we actually use container registries, then we get all the benefits, right, of approved kind of technology, like hashing, layering, role-based access control, and more and more. So for that, we're going to be using Azure Container Registry as our way to store the model. And how this works basically is you have this main footfall inferencing and UI application that before running, we have an init container, so a container that runs before the main container runs. And we'll connect to the Azure Container Registry. We'll pull the model. When pulling the model, we're going to check, right, using Microsoft Entra ID, we can just check, hey, does the container have the correct permission to pull the model? Once finished pulling it, we'll put it into a persistent volume, just storage inside Kubernetes. And then the main application will mount that same volume. And you can see here, like the frames, right, from this camera will go into the video capture. We'll grab that video feed. We'll divide it, right, into different frames. We'll send it to the video processor that will just do the inferencing with that model. And finally, we'll send it back, right, to the main user to see it. So let's go ahead and do a quick demo of how this is looking. OK, so the first thing I'm going to go ahead and show, it's actually my container registry. So this is just Azure. I'll just go here. I have my Ignite ACR. And I want to go here in repositories. And you can see that I have my containers, right, in particular, Footfall AI API. That's a container I was talking about. But also, I have this 𝗬𝗷 model. This is the actual model. This is the PyTorch model that we'll be using. Same as any other container is here in my container registry. The other thing that I can actually do is go to here to tokens, right? And I can see that I have a secret called ACR secret that has this scope map. And I'm just saying, hey, this secret can only read and write my model. And that's how I'm going to bring the model after into my cluster. So how would you do it without container registries? Probably would look something like this, right? So you would have something like wget, right? You get into an endpoint and you just download it directly right into your local cluster. But how we're doing it with ORAS, right, and the container registry is what we can actually, we'll get the secret, that same secret that I was talking about. And now I can just go ahead and put that secret into my Kubernetes cluster. I can use even, like a key vault if needed. And I can just go ahead and do ORAS pull, same as you do a Docker pull. It's just, right, a container. It's just a model that you just run it like that. So with that, you get the model right into the cluster. And I can just go ahead and now show you how that looks. So if I go into the logs here, and I just go into this init download model, right, you can see that it was just downloading all the model directly from the container registry. And how this looks end-to-end, I'm going to go ahead and show one of our interfaces from Contoso hypermarket. So I'm going to go here, main UI, we're actually in Chicago, so let's go ahead and show it. And this is just one of the, we have different roles. I'm going to just go on maintenance worker, right? And this is going to just go ahead and load those cameras. Could take a bit, right? And there you get the cameras. We got people counting right now, right, doing the inferencing and giving back, right, all the way to the final user. With that, we got our model in our cluster. Pretty cool. But what about all the other dependencies? What about all the other containers that we have? How we make sure that we keep those secure? And in the past couple of years, Kubernetes grew a lot, yes, but it's not secure by default, right? So there's a lot of things that we actually need to bring into your Kubernetes cluster to make it secure, apply network policies, apply different kind of configurations to the pods to actually make it secure. We can actually see that in the last 5 years, the Kubernetes vulnerabilities went almost 4x. Recent studies are showing that 87% of the containers, they have critical CVEs. So it's really difficult to keep up to date with all these CVEs and keep your Kubernetes cluster secure. So for that, I'm going to show you a quick demo also of how you can use Microsoft Defender suite of products in order to just go ahead and just check the different kind of pieces, components that you have in this Kubernetes cluster. So the first thing that you can do is actually check your containers, your applications while they are on rest, right? You don't need to bring those containers into your Kubernetes clusters if they have CVEs. For that, we have Defender for Cloud. It will actually scan your applications directly on the container registry, right, while on rest, and will give you alerts of what's happening there. The second piece is just making sure that you're keeping track of your node, right, your Linux operating system that you're running this Kubernetes node. And there, of course, you're going to bring a lot of packages, right, from third-party providers. Let's say if you're using GPU, of course, all the drivers, right, and all the kind of packages that you have on Linux. So how you keep track of all those packages and configurations on the Linux node to make sure that they're up to date and with the correct security posture. And the final, it's inside your Kubernetes cluster, right? How you make sure that all these plugins and all these pods are running in a secure way. So we'll go over, again, a really quick demo on how to do this. Let's go ahead and just check it. So I can go ahead here. This is just Defender for Cloud. I'm going to start also again with my ACR and start looking into my, my images that I have out there. So Ignite, ACR, let's go here. Yeah, so I have it here. I can go ahead and check. I have 7 images, and in particular, I can go ahead and see that, well, we have some vulnerabilities that must be resolved, so I can go ahead and check those. We can see that we have, by severity, we have 11 high, some medium. I want to check what is out there. And I can see it here. I can actually check one specific CVE and see, it's going to give me the explanation what is happening. But the most important part is that it's actually telling me in which of my containers I have these CVEs. And I can then, you can take, some actions in order to patch all these kind of containers. The second piece was actually checking, my node. And to do that, I'm going to just go ahead. I'm just running an Azure VM, right? But this could be on your prem kind of device, right, or Linux device. So I have this kind of VM that is running Linux. And again, I get a lot of alerts and a lot of things of what I should apply to my VM, to my Linux kind of operating system in order to get up to date. And the final thing, it's actually going into the Kubernetes cluster. So I have it one here, right? And again, we're going to get a lot of things that we need to apply into our cluster, into our pods to make sure that it's running correctly, using the correct security posture. So you can see, for example, here, well, privileged containers, of course, they should be avoided. We have maybe you need to enforce CPU and memory usage. So again, alerts that you can go ahead and use Defender in order to get better security practice on your whole infrastructure. With that.
So one of the things that are important to take out of these type of demos is to realize that, again, I've mentioned the messiness of the real world. One of the things that we keep pushing forward is Azure Arc. And what you saw, just in this example, the Azure Arc-enabled Kubernetes, and that Defender integration is a super powerful integration, especially when you are starting to mix it up a bit. When you put Azure policy, for example, with the contextualization of Microsoft Defender for Cloud, and then you start enforcing these type of fixes or patches that you can apply against those CVEs, this is where things are becoming much more powerful, and especially in the context of Contoso hypermarket, right? Because when you have global distribution, right, and you have all these Kubernetes cluster, all these satellites, right, you need to have a way to kind of manage things at scale. So that's really kind of the important piece to take out of this. But we're not done yet. We have a lot more going on. So the next piece that we want to talk about is the context of GPUs and why are those important. I've been walking this week in the show floor. I saw some of the things that are happening with the different vendors. And one of the things that really caught my eye, and shameless plug, we knew about this, is the things that NVIDIA are doing. So what you see here is actually a 3D rendering visualization that is coming from one of the integrations that we did with NVIDIA, and more on that later on in the session. But the point here that we want to make is, in the world of computer vision, and as customers are trying to adopt more and more of these type technologies, right, and the fact that the horsepower that is needed in order to run these models is getting bigger and bigger, GPUs are becoming a critical piece in the architecture. So basically what you're seeing here, I know it looks like maybe a Pac-Man machine, but it's not. That's really a 3D rendering that is happening, like the things that you're maybe used to see in crypto mining or things that you're used to see in gaming, right? Now you can also harvest that power to do some real-life stuff. So that's really why we want to invest, in the next section, we want to invest a bit more and talk about the importance of GPUs in the context of video inferencing, right, and computer vision.
OK, thanks, Lior. So let's go ahead and talk a bit about these challenges, right, with GPUs. So the first challenge, right, is of course scaling, right? Apps that have models that have, GPU. One thing is just running, as I was showing, a small YOLO model. A totally different thing is when you're running, like 3 different, models where you're running, right, racks, you're running SLMs, right? So just that, we're going to go a bit about that. The second one is how you leverage GPUs. So if you think about how you use a GPU for these custom vision applications, as I said before, right, it's just frame by frame. You're doing custom vision. It's a continuous approach. Probably a small model, right? It's not, you don't require a lot of power from a GPU. But if you just think about an SLM, for example, right, this kind of, let's say, ChatGPT, basically it's just you type a question. It needs a lot of power from a GPU. It executes a query. It goes back to the user, and then that's done. You just use it for a couple of seconds, maybe 10 seconds, right? And that's it. So you don't want to be using that GPU 100% dedicated to only the SLM, because you have other applications that you may want to use it. And then the last kind of challenge is about getting the data back. Like as you start using your models, you want to make better and better models. You want to get that data back so you can keep retraining, right? And you can get better performance on your models. So we're going to talk a bit about another kind of, it's Shopper Insights, kind of the same, right? We're just like having some video feed, and we're going to be doing inferencing. But here, I want to just talk a bit about the first two, and what are the things I need to consider when doing this. So the first thing I need to consider is just all the packages that you need to put on that Linux operating system. If you're using NVIDIA, for example, right, you have to use CUDA toolkit. You need to use drivers. You need to use a container toolkit. If you're using iGPU from Intel, again, a lot of runtimes, a lot of drivers that you need to consider. The second thing, right, or maybe the third thing is you want to allocate these GPUs in a dynamic way. So for example, if you're getting a lot of load because you're getting a lot of inquiries on that kind of copilot, right? You want to put more emphasis on that rather than your custom vision, and maybe you can have some buffer on that custom vision. So you want to make sure that depending on the stress that you're having on that Kubernetes cluster, you move you move that GPU if you just assign more cores or less cores. The third, and then the fourth thing, of course, is that assignation of the core. So we're gonna be seeing how you actually, for example, you can get one GPU. Let's say we have a Tesla T4 in this demo, and you don't want to have just one, and assign one to application. Maybe you want to divide that GPU in 4 small GPUs. And that division can be depending on performance. Could be, for example, in time, like you want to assign 50% of one cycle to one application. You want the other 50 to the other application. And then we're going to just show really quickly, right, how this is running directly, right, with GPU, with an NVIDIA GPU, right, and how you can just share that across different applications. So for that, the first thing I'm going to show you, right, is really quickly how this is running. So basically, you have this GPU operator. This is just how the Kubernetes cluster is detecting that we have a GPU there. You can see that here you have all the kind of NVIDIA pods that are running, just making sure that you can also reuse the GPU depending on that kind of stress that you have for these nodes. So I'm going to go ahead now and show you different how you actually assign this GPU. Just quickly go here. Here. Oh, sorry, here. And I'll go ahead into Contoso Hypermarket, which is what we were doing, and I can go ahead and do the describe. And as I go all the way to the assignation, you can see that here you're just saying, hey, I'm going to go ahead and use one GPU. In particular, what I did for this demo, I got my T4, and I just sliced that kind of whole GPU into 2 small GPUs so that I can just share the GPU across the different applications. So I have one GPU that is assigned to that application, and then the other GPU, or the other, let's call it virtual GPU, right, is assigned to these shopper insights. So how does this looks, right? I can just go ahead and show you, one dashboard that we have for this GPU usage that we're doing shopper insights. I'm going to go ahead and show you here. We're just detecting people, we're detecting based on what's the different age, right? And we can see, for example, okay, in this particular case, we're getting 5 FPS, and depending on how we change that assignation, we're going to get more, less, or more. So I'm going to go ahead and show you the footfall directly that we have here, and probably this one has a better assignation of that GPU. I know it's not showing, but I'll just go a bit to do a zoom. And for this one, so for the other one, we're getting 4 FPS. In this one that we have more GPU assigned, we're getting almost 40 FPS, so 10x, right, just because of using a better utilization of that GPU. Let's go ahead into the final. We're missing one, sorry. And the other piece of what you need to consider is actually how you are bringing that data back, right, in order to retrain your models. And as a developer, I don't want to care, right, of how that kind of frames get into the cloud. I just want to store those, like if I find something that is weird, let's say I'm looking for people and I find a cat, I find a dog. Well, that's an anomaly. I want to just go ahead and store that video, store that frame, and it just gets to the cloud. As a developer, that's what I want. So I want to go ahead and show you how you can do that, right, using Azure Container Storage Accelerator. So it's a new kind of product we have inside Microsoft that basically runs on Kubernetes. And will actually replicate all your local storage all the way to the cloud. So in this specific example, what we're doing is exactly the same application, but now we added this step number 6, which is a capture logic. And basically that is just business rules that we say if we find something, store the video, and that will get all the way up to the cloud using this Azure Container Storage enabled by Azure Arc. So let's go ahead and show you how that looks. So I'm going to go ahead and go back to my cluster. This is running, again, Shopper Insights. And in particular, I'm going to go ahead and share that Shopper Insight had a specific persistent volume. So a persistent volume, just this type of storage that you have in the Kubernetes cluster. And if I go to the one that is actually assigned to Shopper Insight, which is this one, it's called ACSA-PVC, so persistent volume claim. I can go ahead and check here that is the storage class. It's a cloud-backed storage class. So again, this goes all the way up to the cloud using this technology. So how does this look from a developer perspective? It's really simple. As you can see in this kind of code, what I'm doing here, and I'm going to go ahead and just show you, this is just checking that a local folder exists. And if that local folder exists, then I'm just, sorry for that, I'm just loading, I'm just go ahead and saving frame by frame everything locally. What happens, right, is that this gets directly replicated all the way to a cloud using a storage class. So as you can see here, this is just my storage account. These are the videos that are happening right now. I can just go ahead and refresh probably. And I just go ahead and download one and check it. And there you can see this is just a specific, really small video of one of the person. I just go ahead, let's go ahead and download another one, maybe a bigger one. Let's go and download this one. Right? And with that, right, you have all the data that you need in order to start retraining your model and getting better, right, and better performance on those models. So, yep.
So again, when I amplify something here, the integration with Azure Container Storage enabled by Azure Arc, this is part of this all kind of another component is part of this all adaptive cloud story with Azure Arc, right? Because what you're going to start seeing more and more, right, is this investment on Azure Arc in the context of building on top of existing Kubernetes clusters, and how do we create this type of extensions? I like to call it the extensibility model, right? Because doing things in Azure today, like with AKS, we have full granular control on what's happening on AKS. But think about the fact that we don't have any control whatsoever when it comes to clusters that are deployed what we like to call the far edge. We have no idea what's going on there. But the way for us to actually know what's going on there is to Arc-enable those clusters. And with this extensibility model, for example, what Francisco just showed you with Azure Container Storage enabled by Azure Arc, that's part of the integration, right? The deployment of the model, right, with container registry on an Arc-enabled Kubernetes cluster, right? That's another powerful integration. We talked about the security. So again, remember that as a kind of a recurring theme when it comes to that extensibility model, stretching our capabilities to the far edge. That's really what we're trying to do here. And we're going to talk about that a bit more right now. So everyone are telling you that there's no AI without data. They're right. There's a good reason why they're saying that, because at the end of the day, AI models are relying on data, right? Without that video inferencing, without that RTSP feed, without that files that are coming to the cloud, that are replicated to the cloud, right? There is nothing for you to train your model against. So that's why data is important. So we're going to show you a couple of examples here to the importance of data pipelines. But before that, let's talk about the challenges, right? When it comes to data pipelines, first of all, you need to understand what are the sources that you are dealing with. What are the type of databases or the type of the data sources that you are dealing with? Because that's the first thing, okay, that you need to know in order to make decisions. Second thing is what type of data you are running down the pipes, okay? So another important piece. And how do you actually create some logic on top of the data? How do you reason over the data? Make it make sense out of that, right? So let's explain what we're seeing here, right? Like I mentioned, the real world is messy. It doesn't mean that everything will be kind of nice and clean, but let's try to make sense out of this, right? So let's talk about what we're seeing here. What we're seeing here is just an example to an edge-to-cloud data pipeline. Now, that doesn't mean that that's the only solution. It just means that it's just one solution, right? This session is really about architecture patterns and possibilities, okay? So this is one possibility. Let's start with kind of how we start here, right? We start with basically getting data from Contoso Hypermarket, right? They're getting a lot of data coming in, shopper, or retail commercial data that is coming in that goes into SQL Server. Okay, they also have like OT data, right? Sensors, freezers, HVACs, POC systems, the list goes on, right? All these sensors, all these IoT devices, they're generating tons of data, okay? That goes into a time series database, InfluxDB, okay? And I'll touch on the Prometheus here in a second. But I already mentioned, right, two types of data sources, right? I mentioned relational database, that's SQL, and I also mentioned time series database, that's InfluxDB. Right? So again, remember those challenges, two types of data sources. From there, okay, we're going to Azure IoT Operations. And again, I'm plugging into the extensibility model. Azure IoT Operations announced this week, general availability. Okay? That's another piece of the puzzle to that extensibility model. Okay? I'll show you that in action here in a second. But basically, Azure IoT Operations is designed to create structure around the data that is coming from the edge, okay? That is flowing into those Kubernetes clusters, and then all the way up to the cloud, in order to create a pipeline of analytics, more logic, more reasoning, right? From Azure IoT Operations, let's go to Event Hub. Okay, Event Hub has been there for years. Okay, basically, Event Hub is a trophy cup. That's what it is, right? It's designed to capture all the data that is coming and massage it a bit, and then move it all the way to, in this case, Fabric. Okay, I'm going to show you two possibilities here. A Power BI dashboard that is more designed for sales and commercial, and real-time OT dashboard, okay, with Fabric. So just with this diagram, you understand that could be multiple options, and this is what we mean when we're saying this is not the only way to do this, it's just one way to do this, okay? So let's see that in action.
Number 2.
Sorry, I'm number 2. All right. So let's talk about what we're seeing here. So one of the things that, that we did with Contoso Hypermarket is we have another solution here. It's called Cerebral. I'll talk about it here in a moment. But what we're doing basically is we're generating information. We have a simulator. And what I'm going to do is I'm going to show you how that pipeline in the architecture diagram is flowing through the different pieces all the way to the dashboard. And we'll talk about the, the steps along the way. So what I have here is a Cerebral simulator. And I'm going to go here to the pod. And let's take a closer look at what we're seeing here. The first thing that you're seeing is basically data that is flowing into InfluxDB, also data that is being published by MQTT, right? Known protocol, been here for years, nothing fancy about that. But the point here, and remember that that's one data source that we are plugging into, okay? So that's the real time. Now, another type of data that we have is sales data. So this is what you see here. Save sales data to SQL Server. So what we're doing, we're generating that data in order to explain how you can actually build those data pipeline, right? So that's the first step, okay? Putting the data into the right database, okay? And there is a critical piece here for you to understand. Using the right database is the #1 thing that you need to think about, right? Because you can use the wrong database, and then your data is just useless, basically. So that's why we're using transactional data for non-real-time data, which is the sales, the commercial stuff, okay? And that's why we're using basically real-time or near real-time, time series database like Influx for the OT data that is more real-time oriented data, okay? All right, so that's the data. Now, let's take a look at how does that look behind the scene, okay? So first of all, I'm going to talk about the SQL stuff. So here I have Azure Data Studio. I have the 2 clusters, basically, or the 2 SQL servers that are deployed. This is, by the way, SQL on Linux, okay, that is deployed on those Arc-enabled Kubernetes cluster, right? So I have those 2 databases deployed. I'm just going to use Chicago because we're in Chicago, and Seattle doesn't have power right now, so it's not working. I'll use a retail DB here, and I have a bunch of tables. I'll show you some examples, right? We'll do a select top 1,000, and I'm also going to do the same for products, right? And you can see here that this is data that is really non-real-time data, okay? Transactional data. This, what I'm showing you right here, is basically the store ID or inventory ID that is mapped to the store ID. And here I'm showing you some products, okay? So bananas, eggs, avocados, okay? All those good stuff. Now, this is the SQL data, all right? Now, let's talk about how the OT data looks like. So this is MQTT Explorer. For those of you not familiar with the tool, awesome tool. Great to visualize basically how data is coming from the edge to the cloud. Important piece here to understand is that data that is coming from the edge to the cloud, okay, before it lands nicely on a Fabric dashboard, which I'm going to show you here, right, it's very non-human friendly, okay? And to show you why it's not human friendly, it's just enough to look at what you see here. So this is not something that is easy for humans to read, right? This is machine language, okay? So this is basically the schema, right, you're seeing. You can see here that, I have brightest levels for the, in this specific case, what I'm looking at is I'm looking at the lighting system, right? So this is the lighting system. I'll show you another example here. I'll show you the HVAC, right? And you can see different types of data that is coming in, right? Celsius, we have that temperature right here, power, humidity, right? So I would argue that this is not, human-friendly way to look at this type of data. It's also not scalable, right? You need to make sure that you have a way to aggregate all this data and then reason over that. So this is how it looks like, behind the scene. All right, let's move on to the other stage of the data pipeline. Now that we have the data in the right databases. The next stage will be Azure IoT Operations. So this is the Azure IoT Operations portal, or the Azure IoT Operations Experience portal, how we like to call it. And this portal is designed more for the maintenance workers, the OT, okay? Now, I'm going to pick here the Chicago cluster. So if you notice, this is an Arc-enabled Kubernetes cluster, like I mentioned. And again, you can see, bunch of data on the cluster of Azure IoT Operations. Not super critical for what we're talking about right now. But what more important here is the data flow. So what we're looking at here, this is data flow. And data flow is a powerful feature of Azure IoT Operations. It's designed to basically contextualize data, massage data, at the edge before it moves to the cloud, right? So what we're seeing here is just a data flow, okay? And you will notice that the source here is the MQTT broker. That's coming from Azure IoT Operations. So Azure IoT Operations has its own MQTT broker, okay? We have the transform phase, and the transform phase is optional, right? Basically what you can do, so for example, converting Fahrenheit to Celsius, right? Or again, other measurement, other metrics, other things, or other massaging that you can do, right? And eventually you have the data flow endpoint, which is Event Hub, and the default is MQ, right? So remember that I mentioned that after the data is coming to Azure IoT Operations, from that point it moves into Event Hub, right? To basically get organized when it comes to the messages, right? And from there, the last step will be Fabric. So let's go ahead and go to Event Hub. So here I have basically an Event Hub namespace, topics, messages coming in, or messages coming in down the pipe. And I'm going to open here Data Explorer as part of Event Hub. And we'll pick Contoso, newest position. And this is basically going to show us the latest events as they are coming in, okay? So what we're looking at here is we're looking at events that are coming from the simulator. You can see it here, that simulator that I mentioned, right? So Event Hub is basically aggregating all these messages. And from there, now we have smooth sailing to Fabric. And how does that look like? Basically, two types of dashboards that I want to show you. So remember the SQL data, that's the relational database, that's the sales, commercial data. So that's how it can look like, okay? Again, no wrong answers or no right answers. You can design your dashboards the way you want. This is just how we designed the dashboard. And this dashboard is just designed to show commercial data across multiple stores, right? Different inventories, stuff like that. Again, classic Power BI implementation, okay? Now, the other dashboard, in my opinion, is a bit more interesting because this integration of real-time analytics, right, with Fabric is super powerful in the context of Azure IoT Operations. I showed this early this week. And what you see here is the Fabric dashboard or the Fabric workspace that is connected to this Event Hub that I just showed you. And basically, this is just show you the, again, the visualization on that data that look pretty nasty in this weird schema, you know, that is coming from the edge, right? So eventually, our goal is to take this data that is non-human readable and go through the pipe, that's the data pipeline, and land it here in Fabric, okay? So what we did here, I was just going to show you, you know, an example of data pipeline. Where's the clicker? All right. So what I just showed you is an example to a data pipeline, right? Now, another important piece of data pipeline is observability, okay? Observability is, you know, like you can implement observability on, you know, on your stack, on your technology stack in so many different ways, okay? And so many different solutions can be out there. What we wanted to showcase is actually Prometheus and Grafana for real-time observability. And the reason that we picked that is because Prometheus and Grafana are the de facto standard when it comes to observability on Kubernetes environments, okay? By the way, you also have Grafana or Azure Managed Grafana in Azure. If you want to use that, you can definitely do that. Okay? We wanted to implement the open source version of Grafana because of the lightweight notion that we're trying to deliver here, okay? Because when you're talking about a factory floor, you're talking about, you know, a restaurant, you're talking about, you know, a place that doesn't have dedicated IT or dedicated maintenance, right? You want to make sure that things are, you know, having less dependencies as possible, right? And they're also taking less space or compute power. Okay, so that's why we went with this Grafana implementation. So quickly, let me show you how does that look like. Thank you. So what we did here is we created multiple dashboards, okay, in order to capture that data. Again, remember, no wrong answers, no right answers. There are multiple ways to implement this type of stuff. The first dashboard that I want to show you is just a general Kubernetes infrastructure, good old Kubernetes infrastructure dashboard, okay? Compute, memory, storage, all those good stuff, okay? But again, data, that's what I'm using here in order to create this dashboard, okay? That's why it's part of the data pipeline. Second dashboard that I wanted to show you is the point of sale, okay? We talked about the Fabric OT real-time dashboard. That doesn't mean that you cannot that you cannot use the same methodologies or use the same thing with Grafana. It's just a different implementation, okay? So it's all about the architecture patterns that we're trying to land here. So that's the point of sale dashboard that I wanted to show you here. Okay, no time to go into all the weeds and all the details. Feel free to come after, we'll talk about it. And the last dashboard that I wanted to show you is the OT dashboard, okay? So HVAC, humidity, temperature, refrigerators, lighting system, all of this stuff are implemented, pumping into Grafana, right? So that's another implementation that I wanted to show you. All right, as we're wrapping up here, oh, I had a good slide before the demo. Ah, I forgot. All right, so imagine I didn't do the demo and I show you this slide and now I did the demo. All right? All right. I thought it was a good joke, well, whatever. All right. Let's talk about getting started. So all the things that we show you today, this week we announced Contoso Hypermarket as part of our Jumpstart Agora third scenario, okay? So Contoso Hypermarket is really where you're gonna be able to start playing with all the things that we showed you in this session and some more. There is a lot going on here. I'll show you this in a second, okay? And also as part of Contoso Hypermarket, what happened here?
I don't know.
Okay. That's weird. That's Unicode. All right, so part of Contoso Hypermarket, we also have Jumpstart Cerebral. I'll show you that. So Jumpstart Cerebral is basically our implementation for what we like to call hybrid AI chatbot, to reason over data. Let me show you this real quick. So I'll flip over to, we're good? All right, so let's take a look. How does that look like? So first of all, how you get started. So this is the Arc Jumpstart website. If you go to Agora, now you're going to have new scenarios. That's a Contoso Hypermarket scenario, right? All the details that you need are in this scenario. This image right here might look familiar to you. That's the one that I actually used at the beginning of this session, okay? Just to kind of demonstrate the fact that we are eating our own dog food. This is really the implementation that we just showed you today. So Contoso Hypermarket has tons of good things in it, computer vision, analytics, edge to cloud, data pipelines, and more. Now, the cerebral thing is also an interesting one. If you watch my theater session with Armando, my friend, we talked extensively about cerebral. Cerebral is super cool, and it's basically our implementation for, like I mentioned, chatbot that is kind of hybrid AI. It can take data that is coming from the edge, which is more the private AI, or data that is related to the business, and can also interact with OpenAI, right? So let me show you an example, and this is something that, again, you'll be able to use right away as you deploy Contoso Hypermarket scenario. So let me show you an example here. So I'm the maintenance worker right now, and I'm asking Cerebral, help me troubleshoot my HVAC system. And as I'm doing this, you can see that Cerebral is already giving me the right information, okay, in order for me to troubleshoot. But here's the important piece here that you need to remember in the context of Cerebral, right? This data that you're getting here, this is actually coming from a PDF that is deployed or is injected into the pod that Cerebral is using, okay? So this is private data. So think about the use cases that you have around private data and troubleshooting guides or just information on manuals, that you can give to your workers and people that are onboarding to organization. This is where this is shine, okay? And obviously there's a lot more examples. Come after, we'll talk about a bit more. We just wanted to show you that specific example.
Just to add, right, all the data sources that we talked about are already integrated with Cerebral. Influx, SQL Server, Prometheus, it's all there, and you can go ahead and query directly. And with that, not this one.
The Unicode.
We also want to announce we went generally available with Jumpstart Drops. So if you're not familiar with Jumpstart Drops, that's another kind of product that we have inside Jumpstart. It's a curated list of kind of scripts, sample apps, tutorial guides. We're trying to create a community here. So if you have any type of code that you want to go and share there, you go ahead. You can just go to Jumpstart Drops. It's really easy to upload your code. You get a lot of telemetry, insights of what's happening, and you also get the whole community of Jumpstart that will start using that. And with that, I'm going to go ahead and quickly show it. How does that look like? If you go, again, to our page, you're going to see here Jumpstart Drops. You'll go here. You had a lot of ways actually to filter, which is pretty cool, right? So you say, Ansible, you're a beginner, what products you're looking for. And in the end, there's a lot of, code that, is created by the community and for the community. In particular, we have one of the latest that we just announced here as part of Ignite also, which is this NVIDIA Omniverse. This is a great partnership that we did with NVIDIA. And again, we talked about Azure AD operations, we talk about GPUs, we talk about models. So you can just go ahead and check it. It's really simple. You just can go ahead, download the code really quickly, and run it, right, and get this exact same thing that we're talking about here in your machine really quickly.
Yeah. So with that, just if you're not familiar with the URL, super easy, AKMS, Arc Jumpstart. Thank you so much for joining us. Have a great party later. Appreciate all of you.